What are the three symbols you need in a flowchart? Well, 1, 2, 3. What are the 4 symbols you need in a flowchart? What's that?
Second.
Yep. What's that?
Rectangle.
It's a rectangle. Yeah, what does it represent? I got one guy who's probably been up all night. I got another guy who has ridden 30 miles on a bike and is just about completely wasted.
Which guy's that?
Rod said he was 30 miles today. So his muscles have removed all the blood from his brain.
I've got muscle sleep, I just had a long way. I have less than 10 a.m.
Okay, this is a statement. This is an instruction. This is something to be done.
What was the circle again?
It's a start. It's where it starts. It's a terminator. Start, stop. What's this represent?
Conditional statement?
Yep, conditional statement or a test, that sort of thing. And then, what is this?
Finish.
Yeah, finish. Start, stop, begin, finish. Okay,
Stay consistent.
don't give him an easy break.
I'm not.
There you go.
It's gonna say rectangle, he has to stay consistent. It's an oblong circle. It's not perfect.
Perhaps it's a diamond or a quadrilateral. There you go. It's a sphere? No. It says sphere. And these things, ask a question, and the answer is either yes or no. Yes or no. We're a computer. Yes or no. Is it yes? Is it no? Is it 1? Is it 0? And typically you use them to make loops. So if I have a line going up, these lines represent what? This is first and this is next. This line represents what happens in what order. For you nerds out there, this is a graph and these are edges. If you get to the point where you're really nerded it up, everything can be a graph. You connect everything. Entity relationship diagrams are graphs. The relationships are edges. Anyway. Once again, Al is walking out and losing everything. So, this is a loop. Your homework has probably 2 loops in it. 2 loops. You'll have to figure out what those are. Flowcharts are an old way of representing process. So let's take a deeper look. We already talked about what statements were. We looked inside those rectangles. Let's look inside these oblate quadrilaterals or these diamonds or these tests, this conditional test. Boolean logic. Remember that old crazy guy Boole, Mr. Boole? Yeah, nobody knows who Boole is, the poor guy. Boolean refers to, Boolean means true or false. It's either true or it's false. If I'm doing Boolean arithmetic or Boolean logic, I'm doing something to figure out whether something's true or false. That's all I'm doing. You'll see Boolean in a lot of languages. Remember we talked about variables? And we said variables typically store things? Well, variables can store different types of things, like, I don't know, numbers. They can store strings, that is text. You have some text you want to throw up on the screen, you put it in a variable, you hand it to your JavaScript, and JavaScript throws it up on the screen. They can also store Booleans, Boolean values, true or false. Now, we had statements where we took a value and we put it in a variable. Remember, we had a statement that looked like sum plus equals count. Semicolon. That took sum, added count to it, put it back into sum. It's a little story right here. It's poignant and yet deep. Well, what if you wanted to find out if sum was equal to count? You wanted to ask that question. Well, let's say you were counting up the number of classes that you were registering for, and you had a variable called class, started out and said, well, the number of classes I registered for is 0. Then you added stuff to that later, and you said, oh, I've registered for 1, I registered for 2, you registered for 3. And someone somewhere told you you can only register for 3 classes. At some point, you have to ask yourself, is this variable equal to 3 or not? There's a special operator for that. And that's 2 equal signs next to each other. The one way you can read that to yourselves is you can just say, number of classes is equal to 3? It's a question mark. One way you can do that. It's a 3 right here. 2 equal signs and a 3 and a semicolon. Now you're not saying make number of classes equal to 3. You're asking the computer, is number of classes equal to 3? You're asking that question. In some sense, this is all inside a big diamond on your flowchart. It's a conditional test. You're asking, is the number of classes equal to 3? Okay, so you ask the question. You use this special little operator. This is called a comparison operator. You're comparing 2 things. Comparison. There are other things you can compare. You can ask, is the number of classes less than 3? You can ask, is the number of classes greater than 3? Is it less than or equal to 3? Is it greater than or equal to 3? There's a whole bunch of conditional operators, and different languages have different ones. For example, depending on the language you're in, if you want to say, are these things not equal to each other? Are they not the same? That's all you worry about. All I want to know is, are they different? Some languages, it's an exclamation point and an equal sign. Pascal used to be 2 of these symbols. That one's a little different. Some languages actually write out the word here, greater than, equal to, depending on the kind of languages. But they're all comparison operators. And they're all used in a conditional test. These conditional tests are everywhere. This is one of the big things that computers do. They compare things. They decide, is this supposed to happen? Is this greater than this? Is this equal to that? Comparisons happen all the time. Conditional tests happen all the time. They are used in 2 ways. 2 ways. In one case, you're happily going along and you're executing statements, and you want to do 2 different things. If a situation calls for it, you're going to do one set of statements. If the situation calls for it, you're going to do a different set of statements. And then you're going to come down here and you're going to continue along on your business. So let's say I have a statement where I say C is equal to 0, and then I do stuff. And the question is, C greater than 3? In which case I'm going to go down and do the A stuff, if this is yes. These are just A's, I don't know what's in here. These are B's.
Isn't that C less than 3?
Pardon me?
Isn't that C less than 3 or greater than 3?
Yeah, C less than 3.
Okay.
Did I say greater?
Yeah.
Alright, the question here is C less than 3? So how do we write that in our language? Well, we have a statement, C is equal to 0, semicolon. And then I've got something here called do stuff. And that's actually called a subroutine, so I'm not sure what happens there. But presumably something happens to C. And then I have a statement that is, if, open parentheses, C is less than 3, then I use curly braces. Curly braces. a statement, it's just some statement. Whatever I want to do when C is less than 3. Maybe I want to sign up for more classes. However, if I'm down here, then it's B and B. Alright, so let's do the translation from this flowchart to this language. Everything in a flowchart can be translated directly into a language. So this is pretty simple. There's a statement, here's a statement. This statement is basically saying, go off and do a whole bunch of stuff, and I don't want to know what it is, I'm just throwing that off into a function somewhere, it'll come back, something will happen. This diamond corresponds to this if statement and this else statement. This if, in fact, in JavaScript there's a then, isn't there? I'm going to put a then in there. You'll have to check me on my syntax. If, then, else. If this is true, then do this. If this is true, then do this. If this is true, then this is the yes exit, then do this. So this is the then path. This is the else path. If it's true, then I'm going to do a bunch of statements. If it's false, I'm going to skip all those and I'm going to go straight to the else clause, and I'm going to execute this block. In case you're interested, anything inside of these semicolons, these curly braces, it's called a block. It has special magical properties. What's set inside a block stays inside a block, kind of like Vegas. We don't have to worry about blocks right now. Some languages, blocks are objects themselves. You can hand them around, do things with them. That's kind of cool. JavaScript, they're just places where you organize your code. Okay, pretty simple. Conditional statement. Conditional statement inside the parentheses of the if statement, inside the diamond of the flowchart. Now something you'll notice here, on your homework, you've got a real simple flowchart that has make n equal to 1, then make n equal to 2, and the stuff in the flowchart is real basic stuff. It's real primitive, assign this to this variable. Now in the old days when there was a class system and it's only the lowly programmers actually touched the computers, people would write flowcharts like that, like you see in your homework. We're using it in your homework so that you can understand the association between the shape of a flowchart and the text in the code. We'll help you make pictures out of code so you can see that in your head. Typically though these days, you tend to do high-level flowcharts, and that's what your class flowchart is. It'll tell you, I want to make sure you tell me you're using a variable in class or whatever it is. But you could easily just put, I'm going to find a class in one of these things. And presumably who's ever reading your flowchart knows, well, I know how to find a class. You go to the catalog, you look it up, you find this, you do that. There's a whole bunch of stuff inside this statement that I don't need to tell you about because you already know how to do that. My flowchart is just as clear if I don't give you all that detail. Sometimes flowcharts are very detailed, where you're looking at a particular variable and you're looking at a particular value. Which way you write your flowchart is up to you. It depends on what your audience is looking for. If you're talking to a bunch of marketing people, if you're talking to people who are at the business level and they don't care how it works, they just want to know that it does, you draw a flowchart that's very high level. First we get customers, then we hold customers, and we collect the money. You know, a nice simple flowchart that says something that means something to them. You're talking to a programmer, you're down at the low level. So in your homework, you show me a flowchart that shows how to sign up for classes. You get to make the call how complicated you make that. I give you a flowchart that basically can be translated directly into code, and that's to help you learn how to code. You typically won't see that in industry very often. As I said, as you learn to read code, pretty much you'll see this, and you'll instantly recognize it for what it is, and you won't ever think about anything other than, you won't have to remember, oh, that's what this looks like. You'll be reading code. In the same way that you started out with picture books. And when you saw the word bunny, there was always a picture of the word bunny. We're in the picture book phase. ways of learning how to program. Eventually you'll get away from it. Also, remember those comments? A lot of times you'll see beginner code that the comment is something like, check if C is less than 3. If you see comments like that, two things might be going on. One, someone's teaching you how to program so that they can show you this is what this syntax means. Sometimes you're reading code that was written by a guy who is just learning how to program. He's teaching himself. There's nothing wrong with a comment like that. You'll run into people who have programmed for many years and they get annoyed by stupid comments like that. The stage where you guys are at, simple, stupid, it's all good. It's all good. And if I'm reading your code, the more comments, the better. So if you don't quite understand what an if statement does and you want to write down this is what this if statement is supposed to do, feel free. Again, you won't find that a lot in industry code. I'm working on a guy gave me a bunch of code for a Ruby on Rails website. Very little comments in there. Why? Because if you're a Ruby on Rails programmer, you know a lot of this stuff and how it's supposed to happen. You're supposed to be carrying that stuff in your head. It's the same way if you walked into a 3-star French restaurant, no one would be telling you how to cut carrots. That's just not important. And they won't be telling you how to make a sauce. They'll be saying, I want your sauce to be less salty, and they'll leave it up to you. All right, so what I'm saying here is that there's a great range of options. When you make a flowchart, when you write code, it's just like any kind of design. The level of detail you give me is up to you, but read the assignment carefully, and I'll give you indications of what I want to see. Let me show you one loop, and then we're done. So this is an if statement. This is called alternation. This is a way of using a conditional to see, should I do this or should I do that? Now let's take a look at how we do a loop, and we'll leave functions until Tuesday. Of course, all this stuff is in your materials online, so you can pick this up if you want to. What does a loop look like for a flowchart? It looks like this. There's a bunch of statements. And you want to go through these statements over and over and over until some condition is met. Until something is true or something is false. There's two places, typically the loop is like this, where you're going to do this over and over and over and over again. There's two places where you can put the diamond. Where are they? Where are the two places?
Beginning and end.
Yeah, so I could put the diamond here, or I could put the diamond here. So let's say we do this, we put the diamond here, we come in, we test, should I do this or not? In which case, if it's true, I could actually just not do this loop at all. Yeah, let's see, do I have the money for tuition? Well, if I don't have the money for tuition, I'm not going to go through signing up for classes. So, putting the condition at the top means I might not execute the loop at all. I might never go through this loop. And that's exactly what I want, maybe. I don't know. It's your loop. Let's see what happens if I put the condition at the bottom. Here I start and I go through. There's no test here. I'm going to execute this statement, then this one, then this one, then this one every time. I'm going to go through and execute these statements regardless of what the situation is. When I get to the bottom, I'm going to check my condition. I'm going to say, should I do this? Should I loop? Or should I just keep going? So if I put the question at the bottom of the loop, it means I'm going to execute this loop at least once. If I put it at the top, I may never execute it at all. The other thing that's important to distinguish whether I do my test at the top, if I have to go through the loop 5 times, when I get to here, it's already done once. So what I got to do is check to see if I need to do it 4 more times. If I'm checking up here, I have to check to see if I'm doing it all 5 times. Those are called off by 1 errors. And when you combine that with the problem of starting with 0, the big bug that you find in loops, and I'm saving you hundreds of hours of work here, is you're off by one. You loop one too many times or one too few. And so whatever you're doing doesn't happen once enough, or it happens too much. All right, let's take a look at a simple form of this, where we put the conditional up at the top, and then we have a bunch of statements, A, B, C, D. And the conditional here is C less than equal to 3. And it always comes back around, and it always comes back up to here. It always does the test first. And then when the test says, now we're done, it goes on and continues this way. This is what that looks like. We use something called a while statement. A while statement. So we have, C equals 0, do stuff, whatever. Then I say while, I need a conditional statement, right? Like we saw in the if statement. So I'm going to use my parentheses, while C is less than 3. And I'm going to use my curly braces, because then this is the block of code that I'm going to execute as long as C is less than 3. And my statements are A, B, C. And then I'm going to close the whole loop off with curly braces. And then I'm going to go on and do blah, 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 blah. More statements. This is a while loop. It's your most basic kind of looping structure in programs. Most basic. I applaud those of you who are still awake. Conditional test. So again, we can see the analogy clearly. The conditional test is here. The block is here. And I will execute this once until this is false. So it's saying, while this is true, do this. As soon as this is false, you're going to skip this whole thing. So when C is what? When I execute this statement, what's the value in C? Look at there. I've got a statement in here that says C plus plus.
It's going to
Every
be
time
less.
I go through this, it's incremented. What is the value of C down here?
It's going to be greater to exit the loop.
Yep, it's got to be greater than 3. So if it's being incremented by 1, then I know that at this point C is equal to 4. Every language, every high-level language has at least 3 different kinds of looping structures. The one with the test at the top, like a while. The one with the test at the bottom, like a do until. And then there's usually another one, which is probably the one you're going to use, which is called a for loop. A for loop. There's a kind of loop that you do all the time where you're going to count something. So you've got a variable, and all it's doing is counting something. And you're going to count from 0 to, 4, something like that. And every time through, you're going to increment that variable. That's all you're going to do. You do this a lot. And so there's a kind of loop called a for loop that is optimized towards that. I'll leave it up to you guys to look that up. That's probably the loop you could use in your code for this next week's assignment. Because in your next week assignment, you're just doing a loop a certain number of times and you're adding some stuff up. So I would use a for loop there. There's other kinds you can. Later on, as you get into more cool languages, higher level languages, your conditional tests get to be more sophisticated. You can compare objects, for example. You can ask objects what's going on and they'll tell you. And you can loop based on that. Objects will do their own looping for you. In some of the higher level languages, you can ask pretty sophisticated questions. Variables can not only contain one value, you can have variables that contain lots of values. Those are called arrays, or sometimes they're called hashes. They're like For every person in this class, I want to go through and ask their names. For every person in this class, I want to take their picture if it's okay with them. So I can write that sort of thing basically in languages, in an English-like language. And that's called iteration, where I take a collection of things and I throw it at the language, and the language just goes through each one of those things and does something for you. So this kind of behavior of going through and doing things over and over and over again is what computers do best. And this is the kind of ways that you program them to do that. Okay, so there's nothing due this weekend. It's just a quiz. But I would take a look at your assignment and let me know next week if there's any questions. We are up against a really hard deadline after the final. You cannot be late on your assignments after the final. If you turn in something after the 22nd, it's just ignored. I've got a real hard deadline. So make sure you're up to date on. If you've got assignments that you want that we're turning stuff back in, like assignment 3 or 4, jump on assignment 6 so you don't have any problem getting it for full credit. Thanks a lot.
Is that the last assignment?
6 is the last assignment, and then you've got an optional extra credit assignment that is due after the final that you can turn it. The final is on Tuesday of that week. The last day to turn something in is Wednesday night at midnight.
Excuse me, what was the top part of that again? Where you said that the block is the middle part, but what's the top part?
This conditional test here
Yeah.
is equivalent to this while statement here.
Okay.
And the actual conditional is inside the parentheses. It's the same thing you would put inside the diamond.
Okay.